Okay, so what I want to do today, it occurred to me that we talked a lot about all the transformations that we can do to sine, but we're going to do cosine today. So we're going to do the equation y equals cosine of x, okay? I'm going to do that equation first, and then we're going to analyze. I'm going to do this in my favorite color, baby turd. We're going to do y equals a cosine of bx. So remember, a told us our amplitude, and b told us the number of times that the cosine function, or this function, repeated itself between 0 and 2 pi. Okay? So let's do cosine of x first. Okay? So if you refer back to your unit circle, you will know that when x is 0, and again, we're in radian land right now, but when x is 0, the cosine of x is 1. So I put a dot at the coordinates 0, 1. So that's what I'm going to do. I'm going to put a dot right there, because when x equals 0, cosine equals 1. Similarly, when x equals pi over 2, and again, that's halfway between 0 and pi, so we're talking right here. When x equals pi over 2, cosine equals 0, so we're going to put a dot there. Similarly, when cosine equals pi, remember that's all the way to the left on the unit circle. So if I had my unit circle, I went over through pi over 2 and down to negative pi, or to pi, I would be at negative 1. So that's where I'm going to put a dot. I'm going to put a dot at pi, comma, negative 1. And then at 3 pi over 2, again at the bottom of my unit circle, I'm at 0. And lastly, completing a full revolution around my circle, I'm back at 1 for my cosine. And what that's going to look like, let me get a skinny line here, is it's going to look like so. That's what cosine looks like. After 2 pi, it's going to just do the same thing over again. At pi over 2, at pi, at 3 pi over 2, at 2 pi, at pi over 2, at pi, at 3 pi over 2, and at 2 pi. And then we should get a gentle curve that repeats itself. Just like that. Pardon my crummy artwork. Okay? Same thing goes. Now let's do this in red. We're going to change our a value. We're going to say y equals 2 times cosine of x. Again, my b value here is 1. So let's figure out what the red graph looks like. So if I'm just taking my black graph and multiplying it by 2 at every point, well, when x equals 0, my black graph equals 1, and I multiply that by 2, I should get 2 right here. So that's going to be my first point, is 0, 2. Now, when x equals pi over 2, remember that's right in this area right here, where halfway between 0 and pi. Now, when x equals pi over 2, my black graph equals 0. So 2 times 0, my red graph will also equal the same thing. Similarly, when x equals pi, that's right here, right? When x equals pi, my graph should be 2 times whatever the black graph is. So my red graph is going to be 2 times negative 1, which would be negative 2, and put my dot down here. So I'm going to have a dot down there. Okay? And then, again, at 3 pi over 2, my black graph is 0. Well, 2 times 0 is still 0, so I'm going to have a dot right there. And then lastly, when, and I'm moving my graph up a little bit, lastly, when x equals 2 pi, my cosine is 1. And remember, my red graph is just 2 times whatever my black graph is. So 2 times 1 will give me 2. And then if I make my line skinny and I connect the dots, I go down like this and then back up like this. And if you look, it's just made the graph taller. And it's going to do the same thing from 0 to 2 pi as it will do from 2 pi to 4 pi and from 4 pi to 6 pi. So once I continue that trend, it's going to look, and you see my dots going in, it's going to look like this. Now let's draw. Oh my, I'm a terrible artist. That's what it's going to look like. As a matter of fact, that is so terrible, I'm going to do it again. I'm going to make it right. There we go. And there you have y equals 2 times the cosine of x. Now, if I want to do something that looks a little bit different, I am going to, let's say I want to do y equals 1/2 cosine of x. What's that going to do? Well, it should take everything that you got and make it 1/2 of that. So instead of having dots either at 1 or at 2, I should have dots at 1/2 and 0 and 1/2 and 0 and 1/2 and 0 and 1/2 and 0 and 1/2, and you see them popping up, and 0 and 1/2 and 0. And then I connect the dots with my fat pen. I think I'm better drawing with the fat pen. Oh, I didn't finish it. Oh, went too far that time, didn't I? Because that doesn't go up to 1, that goes up to 1/2. Huh, almost caught me there. So you see how that works, okay? Now I want to look at playing with my b value. So I'm going to erase all these lines. Don't worry, you'll get the opportunity to watch this on your own via YouTube, as always. So let me erase all these things though. And we're going to start anew, except instead of playing with my a value, I'm going to play with my b value. So let's do y equals cosine of 2x. Now remember, my b value's definition is the number of times it completes a full cycle between 0 and 2 pi. Let's play around with the numbers though. So when, again, I'm going to do cosine real quick. Let's see. I like the fat drawing better. I'm going to keep it that way. Okay, so, and then, there we go. So there's cosine of x. Now I'm going to do cosine of 2x in red though. And remember, when x is 0, 2 times x, let me highlight this. When x is 0, 2 times x is 0, and the cosine of that value, the cosine of 0, is 1. So I put a dot at 0, 1. Now I'm going to do pi over 2. When x is pi over 2, 2 times pi over 2 is pi. And cosine of pi is -1. Okay? So now I'm going to put at pi over 2, my value is -1. All right? Now I'm going to do pi. Again, when cosine is pi, it's 2 times pi becomes 2 pi, and cosine of 2 pi is +1 again. So I am back up here. Now, if you notice, I got three main points in cosine. Remember, it's the same shape. I got the top, I got the bottom. I got the top, I got the bottom, and I got the top again. All right? But what I want to do is I want to find the middle point. Where do you think the middle point happens between 1 and -1? Well, it should happen right between 0 and pi over 2, right? Which would be pi over 4, or halfway. So I'm going to have a 0 there. I'm going to have a 0 halfway between there, too. And then I got all the points I need to create a perfect curve. Perfect curve. Now remember, it does the same thing over and over again, but it does it every pi now. So now I go down and up, down and up, down and up, down and up, down and up. And I'm going to go, oh, nope. Before I do that, I'm going to put the dots in the middle there, right? Dots in the middle, dots in the middle, dots in the middle, dots in the middle. And I will finish my sine curve thusly. And look at that. Isn't that beautiful? See what it did? It made it happen twice as often. Twice as often. Okay? Now, if I do blue, in blue, I do y equals cosine of 1/2 x. What do you think is going to happen? How many times do I finish a whole cycle in 0 to 2 pi? Well, I finish half a cycle in 0 to 2 pi. So, half a cycle gets me right. I'm going to do this in blue now. So I start in the same spot, but instead of going from 0, or I'm sorry, from x equals 0 to pi, going from 1 to -1, I'm going to go to 2 pi. So I'm going to have a dot down there. And then I'm going to have a dot up here at 4 pi and 1. Remember, it took me from 0 to 2 pi to finish the cycle with my black curve, but it's going to take me from 0 to 4 pi to finish the cycle in my blue curve, because it goes half as quickly. And then here it'll be at -1 as well, and it'll be like that. So you see how those things work together. This should be enough for you guys to do your homework today. The rest of the hour is a work day for you. Be nice for Mrs. Evenson, and have a great afternoon. Seniors, if you're here, enjoy your summer, and best of luck to you.